Way up on a big hill in Granada, Spain, sits a magnificent place called the Alhambra Palace. This wasn't just a pretty home for kings, it was a fortress, a stronghold built to keep people safe. Its story began back in the 14th century, a time of battles and shifting kingdoms. The ruler, Muhammad ibn Yusuf ben Nasser, picked this spot for a very good reason. Being high on a hill makes you hard to attack. Enemy armies would have to climb a steep slope just to reach your walls, which is a tough job when people are shooting arrows at you. This strategic location gave the people inside a huge advantage, and the Alhambra was built to last. But this brilliant defensive plan came with a massive headache, a problem that needed a truly dirty and clever solution. The palace was perched 700 meters, or about 2,300 feet, above the nearest river, the Darro. That's a long way down. A palace, especially one as grand as the Alhambra, needs a lot of water. You need it for drinking, for cooking, for cleaning, and for keeping the beautiful gardens alive. You can't just tell 1,000 people to walk down a giant hill with buckets, fill them up, and walk back up, all day. That would be slow, tiring, and create a security risk, an open door for your enemies to waltz right in. So, the engineers of the Alhambra faced a question that seemed impossible. How do you get a whole river's worth of water to flow uphill? This wasn't a job for the faint of heart. They needed a system that was reliable, secure, and powerful enough to supply a small city living inside the fortress walls. They couldn't use electricity or modern pumps. Those things didn't exist yet. They had to rely on their brains, their hands, and the laws of nature. This challenge was the start of one of the most incredible engineering feats of the ancient world. They had to defy gravity itself. The builders knew that a simple well wouldn't be enough. The amount of water needed for thousands of residents, lush gardens, and royal baths was immense. Manually lifting that much water was out of the question. The solution had to be something automatic, something that could run day and night without creating a weak spot in the palace's defenses. They had to think bigger. They had to think smarter. Their answer wasn't just about moving water, it was about taming it and making it do exactly what they wanted, hundreds of meters above its natural home. It was a dirty, difficult job, but someone had to do it. The engineers started their project not at the palace, but miles away at the Darro River. They weren't looking at the part of the river flowing peacefully below the hill. Instead, they hiked upstream, following the river as it snaked through the mountains. They were searching for a very specific spot. After a lot of searching and measuring, they found it. A point on the river that was almost at the same elevation as the palace itself. It was a brilliant realization. If they could just guide the water from that high point, they wouldn't have to lift it 700 meters. They could just let it flow gently downhill, all the way to the Alhambra. With this plan in mind, they began the hard work of digging. They constructed a long, winding canal, a man-made river called the Acequia Real. This channel gently sloped downwards, using gravity to its advantage. It wasn't a straight line. It had to follow the contours of the land, hugging the sides of hills and crossing valleys. It was a massive undertaking, requiring precise calculations to make sure the water flowed consistently without overflowing or stopping. This canal was the lifeline of the Alhambra, a hidden artery that brought the cool, fresh water of the Darro River directly into the heart of the fortress, like a secret delivery service. But even with this incredible canal, the job wasn't finished. The water arrived at the palace, which was great. But it arrived without any real force or pressure. It was like having a garden hose with just a trickle of water coming out. To power the spectacular fountains, the luxurious baths, and the other amazing water features the builders dreamed of, they needed pressure. They needed to find a way to make the water push itself with force. Simply having water on site wasn't enough. They needed to weaponize it, turning a gentle stream into a powerful tool that could bring the palace to life. To solve this new problem, the engineers went higher still. They found a spot even higher than the palace and the canal's entry point. Here they built a huge overhead water tank, basically a giant pool. The plan was simple, but genius: get water into this high tank, and the weight of all that water pressing down would create immense pressure in the pipes below. But this created another puzzle. How do you get the water from the canal up into this even higher tank? It seemed like they were back to the original problem of fighting gravity, but this time, they had a trick up their sleeve. To get water up into that high elevation tank, the engineers dug straight down. They carved a vertical shaft deep into the hill, about 60 meters below the tank. At the bottom of this shaft, they built a well. This well was fed by a channel from the main canal, so it was always full of water. Now they had a pool of water right under the place they needed it to be. The next step was lifting it. For this dirty job, they built a large water wheel inside the hill, powered not by the water itself, but by animals like donkeys or oxen, walking in circles day and night. This animal-powered wheel turned a long chain with a series of buckets or drums attached to it. As the chain moved, the empty buckets would dip down into the well at the bottom, filling up with water. The wheel would then lift the full buckets all the way to the top of the shaft. Once they reached the top, a clever mechanism would automatically tip the buckets over, pouring the water into the overhead tank. This system worked continuously, a non-stop elevator for water, ensuring the tank was always full and the pressure was always high. It was a hidden factory inside the hill, all dedicated to giving the palace its power. With this powerful pressurized water system, the Alhambra became a palace of watery wonders. Water wasn't just for drinking anymore, it was for show. Beautiful fountains shot jets of water high into the air in the courtyards, creating a cooling mist and a peaceful sound. The royal family and their guests had private bathrooms with showers and wash basins, luxuries unheard of in most of Europe at the time. The palace even had a steam room, like a modern spa, and underfloor heating in the bathrooms, all powered by this incredible hydraulic network. Water flowed everywhere, making the desert-like climate of southern Spain feel like an oasis. Perhaps the most amazing feature was the invisible water clock in the famous Court of the Lions. This fountain wasn't just for decoration, it told time. It has 12 stone lion statues arranged in a circle. Inside the fountain, a complex system of pipes was calibrated perfectly. Every hour, on the hour, the system would channel water to the mouth of the next lion in the sequence. If you saw one lion spouting water, you knew it was 1 o'clock. When 9 lions were spouting water, it was 9 o'clock. It was a beautiful, functional, and mind-boggling piece of engineering that worked without a single gear or spring. The genius of the Alhambra's engineers didn't stop with telling time. They made sure that not a single drop of water was wasted. After the water clock in the Court of the Lions ran for 12 hours, with all 12 lions spouting water, it needed to reset. A special siphon pipe hidden inside the mechanism would trigger, creating a vacuum that drained the entire central bowl in about a minute. But instead of just letting this water flow away, they channeled it. The drained water was sent through an underground tunnel to another part of the palace where it was given a new, very hot job to do. This water flowed to a boiler room, where it was heated by a large furnace. The hot water was then sent through a grid of terracotta pipes that ran underneath the floors of the steam room and the main bathrooms. This created a radiant heating system, warming the stone floors from below so you never had to step on a cold tile. It was ancient underfloor heating. After warming the floors, the water was heated even more until it turned into steam, which was then piped into the steam baths for the royal family to relax in. It was a complete, multi-stage system that provided comfort and luxury from a single, clever design. In some parts of the palace, the engineers had one last challenge. They needed to get water up a final, short, vertical climb of about 6 meters to the highest towers. For this they used a mind-bending trick involving a whirlpool. Water was collected in a specially shaped basin. When a plug was pulled, the water would drain in a vortex, a swirling whirlpool. This vortex sucked air bubbles into the water, which made the water less dense. This lighter, air-filled water was then able to rise up the 6-meter pipe, seemingly defying gravity one last time to reach the very top of the fortress. This incredible mastery of water and engineering is a huge part of why the Alhambra survived for so long. While other cities in the region fell to enemy armies, Granada, protected by its mighty fortress, remained unconquered for nearly 200 years. The palace was more than a home. It was a self-sufficient world. It had its own water, its own power, and its own comforts, all hidden behind strong walls on an unclimbable hill. It's a testament to the idea that sometimes the toughest, dirtiest jobs lead to the most beautiful and lasting results. The Alhambra still stands today, a stunning reminder of a time when human ingenuity made water flow uphill,